Hi, I'm Chris. This is a tale about my buddy Praveen and I. Praveen lives in the East and I live in the West. We both love rock climbing, and we like to collect and compare results. We're very competitive. Once upon a time, Praveen and I both kept track of the number of times a month we lifted weights at the gym, and then we wrote down the number of the hardest rock climb we did outside that month. We pushed ourselves to do the hardest rock climbs we could. Rock climbs are numbered in difficulty from 0 to 15. Here's Praveen's data. For example, this point represents his data for March. He went to the gym 10 times that month, and he climbed a 13. That's great. This point is his data for November. He only got to the gym 2 times, and his hardest rock climb was a 7. So based on the graph, do you think going to the gym and climbing performance increase in unison? It sure looks like it. When Praveen increased his gym visits, his climbing performance increased. We can even graph a line of best fit to approximate this data, showing how X and Y increase together. Even though he never went to the gym 6 times in a month, we can use the graph to interpolate that 6 days at the gym would have helped him climb around a 10. We can see from the graph that the data change in unison. That's called a correlation. We also really think there's a causality at work here. We think that going to the gym more caused Praveen's rock climbing to improve. What about me? Well, here's my graph. It's a chaotic mess. In the month of December, I went to the gym 10 times, but I only climbed a 1. And in June, I went to the gym once and climbed a 13. Clearly for me, the data didn't change in unison. There was no correlation between gym visits and climbing performance. And that definitely means no causality. Praveen and I have tracked everything. We even tracked the ice cream we ate. Here are the number of times we each ate ice cream in several months. For example, in 1 month I ate ice cream 3 times, and Praveen ate ice cream twice. In another month, I ate ice cream 10 times, and he did the same. If you look at the graph, it's clear that there is a correlation, that data change in unison. But do we really think that I caused Praveen to eat roughly the same amount of ice cream as me? No way! He eats what he wants. But if there is no causality from me to him, what could possibly explain this amazing coincidence? Ah, the months, of course. The weather in different months is a lurking variable, causing us to change our habits in unison. In cold months, we eat less ice cream, and in warm months, we eat more. The lurking variable is the real reason that the graph shows a correlation in our ice cream habits. This graph shows a correlation without causality. Coincidences like this happen all the time. Don't be fooled. Just because you see a graph that shows a correlation, that doesn't mean there is a causality. Be skeptical. Try to find a lurking variable. In this case, the lurking variable of the month explains the correlation. How about this one? I kept track of my fast food visits per month and my weight at the end of the month. Do you think there will be a correlation? And if there is a correlation, do you think there will be causality? Here's the graph. As expected, when I ate fast food more often in a month, I weighed more. And when I ate it less often, I weighed less. There's a correlation. And is there causality? Although I'd like to blame my weight on something else, we know there is causality. Unless I have some sort of lurking medical condition at work, we are quite certain that my fast food habits are causing me to gain weight. Correlation and causality here. But in reality, our world is awash in coincidences. We can find correlations everywhere without causality. Here's a graph of the revenue from bowling alleys in several years on the y-axis versus the amount of chicken consumed per person in those same years. There's a clear correlation. The more chicken we eat in the US, the more the bowling alleys earn. So eat more chicken and save the bowling alleys, right? Of course not. Correlation here is a complete coincidence. No causality, and no lurking variable that I can imagine. Remember, a graph that shows data changing in unison is a correlation. It's possible that there is causality between the independent and dependent variable, as in the case of fast food and weight. But very often, there is no causality, and instead there is a lurking variable which is causing the coincidence of the data. When Praveen and I ate ice cream, Weather in the month was the lurking variable. It's your job to be skeptical and try to find a lurking variable to explain a correlation you see, or to defend your argument for a causality. Repeat after me. Correlation doesn't imply causality.